Today is the third lecture. So what we are going to discuss is about enzyme catalysis. Enzyme catalysis. So what is enzyme? When you are talking about enzyme catalysis, what is enzyme? Enzyme is nothing but a biological catalyst, which basically increases the rate of reaction of a biological reaction. Okay. So I mean, we know all about the catalyst. Catalyst is basically which ramps up the reaction rate, right? And so if it is happening, any catalysis is happening in a biological system, then it is called enzyme. Okay. So basically what happens is that in a biological reaction, most of the time the reactions without the help of enzyme is the rate is so slow that it seems like it doesn't really happen. So what enzymes does that is that the enzymes ramps up the reaction rate of in biological uh, process at a very faster rate. So we need to understand. I mean, we are not going to discuss much about the biology here, but we are going to develop basically the Michaelis-Menten equation. Okay, so I'll just try to derive. So let me at least write the spelling of Michaelis-Menten equation, right? So I should not make any mistake here in the scientist's name. This is the equation which we want to develop. So as usual, like what we did in case of, say, for example, in Lindemann hypothesis, here also I'm going to we are going to first write the model. Okay. So first what happens is that the enzyme first binds with the substrate, hmm, and forms basically E. And as usual, here we have to put a rate constant K1, and the inverse reaction I will write it as K minus. Okay. And then again ES basically will form P plus E. Okay. So here also the rate constant we have to write K2 and then K minus 2, okay, for the reverse reaction. Okay. So so this is the two-step reaction mechanism. We can write it for a biological reaction. Okay. ठीक है. So what? Let me just write what are they. E is the enzyme. Okay. S is the substrate, and ES the enzyme substrate complex, and P is the product. Okay. So this is the model. So enzyme, as we know, is basically in normal common name is also like the catalyst. Catalyst means we know catalyst means something which catalyzes the reaction, makes the reaction faster by lowering the activation barrier. Okay. So now before we move forward, we want to highlight here is that as you can see, I mean, whenever we ask the students what is the definition of a catalyst, students they say that the catalyst doesn't really catalyst is something which makes the reaction faster but doesn't participate in the reaction. So that's not really true. I have tried to highlight it all the time that I mean it's impossible. Something is not participating in a process but making the process faster. That's not happens. Uh, I mean, this part of the definition is true that the catalyst or in this case, enzyme basically recovers at the end of the reaction. But they do take part in the reaction, as we can see in the first step, that E plus S is forming an enzyme substrate complex. Okay, so the enzyme or catalyst do take part of the reaction, and not only that, they most of the time, more than 99% time, are involved in the rate determining step, means the slowest step, and that's why they reduce the kinetic barrier. And enzyme catalysis we are discussing here, basically in case of biological system, basically in absence of an enzyme, the reaction hardly proceeds. Okay, so the importance of catalysis is much more in a biological system. Okay, so basically what happens in this case is that enzymes are basically at certain sites where the substrate can bind. Okay, so I mean in a simple way, if we try to like understand, say for example, this is basically enzyme sites where substrate comes in and binds. Okay, and forms basically the enzyme substrate complex. Okay, so that is the important part to understand. Now in biological system, what happens, or we'll also hear a lot of time about this term inhibitor. Inhibitors are basically something very similar. Usually what happens is that something similar to basically enzyme sites where the substrate binds but doesn't really obviously able to come out on the from the product, and as a result that basically decreases the rate of the reaction in a biological process. Okay, so these are very important point to understand. And another thing is that important is to understand that usually, as we know, that in the concentration of enzyme is much smaller than substrate. This is an important point for us to remember. Okay, and as we know that usually what we when we use try to understand about the catalysis, we I mean you'll if you go to a lab, then you'll often hear this term the supervisor will catalytic amount. Catalytic amount means the concentration of the catalyst is usually should be much lower than the substrate concentration. Okay, so this is very important for us to understand. So so there are like three common points we have to understand. First is that the enzyme reduces the kinetic barrier that makes the reaction faster by forming the enzyme substrate complex. It and then it recovers at the end of the reaction, and enzyme concentration is usually much less than the substrate concentration. These are very important point to understand. So in short here, this for this point we can write it like, you know, enzyme is present in much less concentration than the substrate. Okay, and if that happens, then also I can write that uh, that es also will be much uh, sorry uh, yeah, so the es will be much less compared to the substrate concentration. That will also be true, that substrate concentration will be much higher than the enzyme substrate complex. Okay, so if the concentration of the, so es is basically, I can say, is the an intermediate, right? And as we know that for an intermediate we use, like, uh, common methodology to basically apply the steady state approximation, right? So that's what again we are going to do. So what is important thing to steady state approximation means, what is our formula? DES is equal to divided by dt is equal to 0, means the change in concentration. Change in concentration of the intermediate is not really high. So that is basically the intermediate concentration doesn't really build up during the reaction, right? So this is basically what we use everywhere, right? So we know that this two approximation is very important, right? This we have to. Okay. So then we will move forward with our normal state. Yeah, I will stop the video at this point and I will come back again.